Hello, welcome back to my YouTube channel. Let's solve the next problem. So, let a sequence an increasing sequence, and we have to show that there is a unique n such that we have this inequality. So, first of all, stop the video and try to think of a solution of this problem, beautiful one, and after that come here and see if our solution are same. First of all, I will try to expand this inequality. So from the first, I will have like n times in less than a sum. And a very good idea is to consider it n times an in the right part, and I will have something like this, which can be written in the next form. Force relation. Right now, I will try to expand the second inequality. Let's consider it like this. Okay. So, what we have in the other part, in the other inequality, is something like this. So, I'll have a0 plus a1 plus an less than or equal with n times an plus 1. So I will have that this sum is less than or equal with 0. This is relation number 2. And right now, try to see that these two sums here are very similar. Their philosophy seems to be the same. So what I'm going to do now, I'm going to consider it Bn, which is a sequence like a0, a1, an minus 1 minus n minus 1 times an. And from 1, I have that 0 is less than Bn, and from 2, Bn plus 1 is less than or equal with 0. So our purpose here is to show that there is a unique n for which these two relations happen. Also, don't forget that terms of an are positive integers. So, Bn is an integer number. Right now, what I'm going to consider it is like to see what is the monotonicity of Bn. Because you see, here we have to show that Bn is bigger than 0 and Bn plus 1 is less than or equal with 0. So what I'm going to do is to consider it the difference between Bn plus 1 minus Bn, which is going to be a0, a1, an minus n times n plus 1 minus a0, a1, an minus 1 minus n minus 1 times an. Here, these terms, it will be reduced, And what I'm going to have is, and also here you know it's going to be with plus. So I will have n times an minus n times an plus 1, which is going to be n times an minus an plus 1, which is going to be smaller than 0. So right now what I show is that bn is decreasing, and it is a sequence of integers decreasing. Also, when I'm looking at b0, or not like b0, let's consider it b1. So when I look at b1 is like a0, which is a positive integer, so b1 is bigger than 0. And right now, let's try to think of the next scenario. So b1 is bigger than 0, but we have b1 bigger than b2, bigger than b3, bigger than b4, and so on. If this sequence it will be of real number, we can have that all these terms are positive, but because we have this sequence of integers which is strictly decreasing, we have to have a number where it will be like a swap. So it's going to be a step when bn is bigger than 0, and the next one is going to be smaller than 0, because we use that our positive sets are a finite set, and also it is bounded below. So when I have that bn is a strictly decreasing sequence of integers, then there exists a unique n for which I will have that bn is bigger than 0 and bn plus 1 is more or equal to 0. What I think that it's important from this problem is to remember that it's very good to consider it a new sequence. Also, try to think not very complicated the problem. Try to take another sequence, try to find the monotonicity, try to find some ways of tackle this problem, because if you look here, after we considered bn, our problem became more facile, more easier, because we just take in consideration the monotonicity, and we were very okay. Hope that you like it. Don't forget to like, share, subscribe. See you with the next problem. Bye bye.